Welcome to the most exciting and practical section of maths, and that's the section of trigonometry. Now this word, trigonometry, is made up of two root words. The first one is trigonon, which means triangles, and the second one there, metry, which means measurement. And so basically trigonometry is all about the study of the measurement of triangles. And we are going to find hundreds of ways to apply it, but it always boils down to this root here, the trusty triangle. And so before we move too far down the road of trigonometry, it is only right for us to make sure that we understand how to refer to triangles. If you have a look at this triangle here, it's a right angle triangle. That's what we're going to focus our grade 10 studies on. And in a right angle triangle, we have got certain things that are always true. One angle is 90. The side opposite that is always the hypotenuse. And then there's also something worth noting about how we refer to triangles. So this we would call triangle ABC when we spoke about it, because sometimes we're going to end up with more than one triangle that we're dealing with, and so it's important to direct people as to where they should be looking. Okay, the corners of these triangles are known as the vertex. Okay, and you get one vertex and you get many vertices. Okay, and the vertex is always written with a capital letter. So capital A, capital B, capital C, okay? And we can also refer to the angle inside here, and when we're doing that, we will put a little hat on it. So that will be angle A with a hat, okay? The angle links to the vertex, so we want a capital there. All right, if we refer to the sides, then we need to change it up a bit, and we need to look. So let's look at this side here. It's side AB, which is fine, perfectly fine to refer to it by the two vertices that enclose it. But the other way that we often do is we'll look at the angle that's across from that side and we'll use that to label, okay? But we'll use a lowercase letter. Okay, so small letter C will refer to the side length there. Okay, if we have a look at this side length here, AC, let's just check that we definitely know how to refer to it. So AC, we look at the angle that's directly opposite, and we'll say that is small letter B. Okay? And then also, because we've been paying attention, that is the hypotenuse. And we know the hypotenuse relatively well because Pythagoras' theorem has been a part of our lives for quite some time. Okay, so just to recap, capital letters for the vertices. If we are talking about an angle, then we use the vertex with a little hat on it. And if we're talking about a side length, look for the vertex opposite to the side, and then you use the small letter there. Now, as part of our trigonometry journey, we are also going to be introduced to a few new variables, and they are actually elements of the Greek alphabet. Okay, and so there are loads of letters in the Greek alphabet, but let's just have a look at these three because they are the most common. Okay, this one that looks a bit like an A or maybe even a fishy, this is known as the Greek letter alpha. Okay, that's the first letter of the Greek alphabet, all right? And so you can make it like a fish or you can make it like an A with a bit of a curly thing on top. All right, the next one we're looking at is the letter beta, okay? And that is kind of like our B, but it just has a longer tail on the end. And then another one that is very common is the letter theta. Okay, so those three things, just like we've been using X, Y, and Z, and will continue to use X, Y, and Z, these letters often represent the variables that we deal with. So what you'll find in trigonometry is that a triangle will now incorporate some sort of unknown angle. Okay, so here angle C is now given the value of theta. And now that we have that, we can actually start to name all the sides of the triangle in relation to this angle that we are dealing with. So what I find is the easiest side to label is the hypotenuse. It is always going to be found across from the 90-degree angle. So follow that one. The longest side in any right angle triangle is known as the hypotenuse. Then what you can do is you can have a look at where your angle is situated. So this angle C here is formed between two sides. One of the sides is the hypotenuse. The other side is the side that is touching the angle, okay? And so it's directly next to the angle, and we call that the adjacent side, okay? Adjacent is just a fancy way of saying next to. And then finally, there's one other side in the triangle. If you look at the angle, theta, in this instance, and you have a look at the side that is opposite that, then that is the way we name it. We name it the opposite side. So what we can do now is we can say that side AB, or side small letter c, is the opposite side in this triangle with reference to theta. Okay? The hypotenuse always across from the 90-degree angle, and the adjacent is always next to or touching the angle. Okay, and it's important to know these because all of our trig ratios link to these three different types of sides: opposite sides, adjacent sides, and the hypotenuse. And here we have them. In any right angle triangle, we can identify three trigonometric ratios: sine of the angle, cos of the angle, or tan of the angle. Okay? Sine is always going to be the opposite side over the hypotenuse. So if we wanted to link it in this particular triangle, we said our opposite side was AB over the hypotenuse, which was AC. Cos is always going to be the adjacent side over the hypotenuse. So the adjacent side is BC and the hypotenuse is AC. And then finally, tan is always the opposite side, AB, over the adjacent side, BC. So there we have our three main trig ratios. And you can see, simply by labeling the sides in your triangle, you can actually express them as side lengths of a triangle. Okay, it's important that you remember these letters. So there are a couple of different ways of doing it. A lot of people just take the first letter. So sine opposite hypotenuse makes SO. Then cos adjacent hypotenuse, ka. And finally tan opposite adjacent, toa. So you could simply remember SO, ka, toa. Or if you remember to always write sine, cos, and tan in that order, then some people like to use the mnemonic, which says, oh heck, another hour of algebra. Whatever method you use, make sure you put these ratios in your memory bank. Now there are more than three trig ratios. We also get these other three. These are known as the reciprocals. And basically they are the upside down version of the ones that they are currently placed next to. So whereas sine was SO, opposite over hypotenuse, cosec is hypotenuse over opposite. And where cos was ka, adjacent over hypotenuse, sec is hypotenuse over adjacent. And where tan was toa, opposite over adjacent, cot is adjacent over opposite. Okay, most of our maths is going to focus on sine, cos, and tan, but these reciprocals can be tested at grade 10 level. Let's have a look at how this can be asked. Okay, so consider the triangles below. Have a look at this. We've got ACB, where B is a 90-degree triangle. And then we've also got CDB, D is a 90-degree. And then automatically that would make this one a 90-degree because angles on a straight line add up to 180. Okay, they're asking us for a couple of things. So they said, write down two ratios for sine of angle A. So here's angle A. And so what I want to do is I just want to start off by refreshing my memory on the SOHCAHTOA. So sine is opposite over hypotenuse. cos adjacent over hypotenuse, and tan opposite over adjacent. Okay, that's going to help me. So when they ask me for sine, I know that I'm going to be looking for opposite over hypotenuse. All right, now they've specifically asked me to refer to angle A. So angle A is inside there at vertex A, and they want two ratios. Okay, so let's just have a look at one triangle at a time. Okay, I'm going to start and highlight this triangle here in blue just so that we can see it. Now with reference to angle A, I need to find the hypotenuse, the adjacent, and the opposite side. Okay, hypotenuse is always across from the 90, so 90 degrees would be there, which means the hypotenuse is going to be here, so H. Adjacent is going to be the one that's also touching the angle. So the angle touches the hypotenuse, and then it touches another side, so that's the adjacent. And then finally, that leaves opposite. Okay, so within this blue triangle, because I have O, H, and A, I can actually already write down one ratio for sine A. And that is going to be opposite. The opposite side is DB or BD. I always like to put these in alphabetical order. Over the hypotenuse, which is AB. So there we go. That's one ratio for sine A. Now I need to take a deeper look because I need to find another ratio. Okay? And so if we extend our search now to this slightly bigger reddish triangle, let's highlight that all the way. Okay? We've got a 90 degree over here. So let's, in red now, identify the hypotenuse, the adjacent, and opposite. The hypotenuse is always the easiest to spot. So across from the 90 degrees, that's the hypotenuse. And so the hypotenuse here is going to be AC. All right, then in relation to angle A, that's always the thing we need to be careful of. Where is the adjacent side? Which other one is touching it? Well, within the red triangle, it's going to be side AB. And that leaves side BC as the one that is opposite. So there, opposite. Okay, so now I can write down a second ratio here for sine. Refers to another triangle, but that's okay. We want the opposite side of the red triangle, so that's BC, over the hypotenuse of the red triangle, which was AC. So there we go, two different ratios for sine of angle A. And now they want two ratios for the tan of angle theta. Okay, so I'm going to follow a very similar process, but now I need to reorientate myself because the angle they want is this one over here, angle theta. Okay, let's start by making a yellow triangle here. Okay, because that's the one that contains the theta. And then I'm going to, again, just assign within that yellow triangle the hypotenuse, which is going to be across from the 90. So hypotenuse there. The adjacent, that's the one that, along with the hypotenuse, touches the angle. So adjacent is going to be the one next to it. And then we're left with the opposite side there. Okay, so when they look for tan, tan is opposite over adjacent. So let's make a note of that, opposite over adjacent. And so let's see, tan of theta is equal to the opposite, BD, over the adjacent side there, CD. Okay, and then they want another one. And so we're going to have to go again into the red triangle because the red triangle was the one that contained both a 90 degree and the angle theta. Okay, but be careful. This A, H, and O that we wrote in here referred to angle A. So we're going to have to rework that out. And let's do that then in a different color. Perhaps we can even just color code over it. Let's color code here. And that's going to just help us to stay focused. So with regards to angle theta and looking at this 90 degree angle over here, our hypotenuse fortunately stays the same. Okay? The angle that is now touching angle theta, the side that is now touching angle theta, is going to be the one right next to it. And then finally, that leaves an opposite side. Okay? And so we've got tan theta is opposite over adjacent. The opposite is this one here, AB, and the adjacent is this one here, BC. So AB over BC. And there you have it. Sine, cos, and tan can be identified in many different triangles as long as you look at the angle and you assign opposite, adjacent, and hypotenuse to that specific triangle with reference to the angle that you are working with.